So let's do this example. Balance the redox reaction occurring in basic aqueous solution. So this is the same process as doing one in acidic solution. There's just an extra step at the end. So I know it's been a while since we did these. The first thing we have to do is assign oxidation states and identify what's being oxidized and reduced. I'm going to go through this quickly because the slow version is available on YouTube. So I'm looking at these, and this one is an element, and so I know that it has an oxidation state of 0. So that one's easy. H2O2 is the next one that kind of appeals to me. Two nonmetals, and so two nonmetals, we think Fe765. So there's no fluorine. Hydrogen gets to be what it wants. It wants to be +1. And then oxygen has to take up the slack. So for this molecule, we have two hydrogens, two oxygens. The overall charge is 0. So all the oxidation states have to add up to 0. So there's two hydrogens. They're each +1, so that's a total of +2. And so the oxygens must each be -1. That's not what oxygen would prefer to be, but it has to just go along there. And then we have ClO2, Fe765, no fluorine, no hydrogen. Oxygen gets what it wants here, it's -2. There's two of those, a total of -4, and so the chlorine is +4. And then over here we have ClO2 minus. So again, oxygen gets what it wants, -2. Two oxygens is -4. The overall charge here isn't 0, it's -1. So the chlorine is +3 instead of +4. And so now we can look at this and we can see that, well, there's no hydrogen on the right side, and hydrogen doesn't often change. We have oxygen going from -1 to -2, and also it's going to 0. And then we have chlorine going from +4 to +3. Honestly, the book gives you this, write the oxidation numbers as the first step. You can actually do these without writing any oxidation numbers, but there was just extra practice for you. So we have to write two half reactions, one for oxidation, one for reduction. So looking at this, I have two reactants here, and I have to pick which goes with each of my two products. Okay, I'm trying to do this away from that, but I can't. I just need to look at the screen. Well, H2O2 is probably not going to pair up with the ClO2 because this has no chlorine in it. The ClO2 and the ClO2 minus are probably something that goes together. And then the other two are going to be the reactant and product for my other half reaction. So I'll write those down. I've got ClO2 aqueous, and that's going to go to ClO2 minus aqueous. And then I've got H2O2 aqueous going to O2 gas. Those are my two half reactions. I balance each of the half reactions, first with respect to mass and then with respect to charge. So if I look at this first one, ClO2 and ClO2, it is balanced with respect to mass. Each side of the arrow has one chlorine atom and two oxygen atoms. It is not balanced with respect to charge, though. This has a -1 charge, and this side has a 0 charge. I balance the charge by adding in electrons. Electrons have negative charges. So I'm going to add one electron over here, and that'll give me a negative charge on each side. For the second half reaction, I've got two oxygens on each side, but I have two hydrogens on one side. So we balance the hydrogens first. No, we balance the oxygens first. The oxygens are fine. We balance the hydrogens by adding acid, H+. So over here I've got two hydrogens, so I'm going to balance that by adding two H+ ions over there. I don't want to put water in here because the oxygens are already okay, 2 on each side. So now I have 2 hydrogens and 2 hydrogens. Now I balance the charge. I've got 0 charge on this side. I have 2 plus 1 charges, so a total of plus 2. To make this side 0, I'm going to add 2 electrons. So now I've got them balanced with respect to mass and charge. Anybody remember what the next step is? We need to multiply to achieve what? Electrons being the same, the number of electrons. Here I have 1 electron on the left side and 2 electrons on the right side. So I'm going to multiply the first half reaction by 2 so that I can get 2 electrons. So I'll put a 2 there, and then I have to multiply everything else as well to maintain the charge and mass balance. Now I can add these 2 equations together. The electrons cancel out. There's 2 to start with and 2 that end up. They just got transferred from one thing to another. They don't show up in the final reaction. And that's why we multiplied the first equation by 2. So then we're going to copy down what's left. So I'm going to get 2ClO2 aqueous plus H2O2 aqueous. And that gives me 2ClO2 minus aqueous plus O2 gas plus 2 hydrogen ions. You can double check and make sure that it's mass and charge balance. If this was an acidic solution, we would stop. But this is a basic solution. So we're not going to have hydrogen ions present in a basic solution. So we have to mess around with this a little bit. We need to neutralize those hydrogen ions by adding an equal number of hydroxide ions to each side. So I have 2 hydrogen ions. I want to add 2 hydroxide ions to this side. And I don't want to mess up my balance here, so I have to add 2 hydroxide ions to that side as well. The reason I did this is when you put 2 hydrogen ions and 2 hydroxide ions together, what do you get? You get 2 water molecules. So I'm going to cross those out and write what they react to form, which is 2 H2O molecules, and that will be in the liquid state. Now this reflects the reaction in basic solution. Sometimes when you balance an equation like this, there might be H2O, other H2Os in the products or the reactants, and then you have to take care of those. But that's not usually a big deal. That was a whirlwind. Any questions? Stunned silence. To be expected.